Alright, question number 17. An aircraft en route place A to B reads on ADF a relative bearing of 188 degrees to NDB A and 008 degrees to NDB B. Then you're asked to find out where is the aircraft relative to the track. Is it on track, starboard, off track, or port of track? Let's see some situations here. Let's take two different NDBs, NDB A, NDB. And as we have discussed earlier, NDB can be used to define an airway. So you can see this airway is defined by a particular QDM, from this QDM of 270 to NDB A and a QDM of 090 to NDB B. That defines this particular airway. Now imagine an aircraft that's exactly at the it's en route between A and B, and here we assume that there is no wind. Therefore, your heading is equal to your track. Right? Now, what do you think is the ADF indication? The ADF indications would be. So, RMI, if you have two different needles, you tune in the RMI to or RBI to two different NDBs. So, one dial will be having two needles. Right? So, to understand the indication, two different needles. If you tune to NDB A and NDB B, so towards NDB A, this is going to be indication. What is this indication here? Since the aircraft is moving away from station with zero drift. Why zero drift? Because there is no wind. Right? It's going to indicate 180. Right? What about this needle here? When you tune the same RBI to NDB B,
0.
that's going to indicate 360 or 0 degrees. Right? Very hypothetical scenario because there's always wind. Now, same case, if I place the aircraft to the starboard of track, in this case the aircraft is on track. If I place the aircraft with on starboard of track, so this is what the aircraft did all the way. Tuned to NDB-A, it just drifted off to the right. This happens if you don't compensate for wind. And if you start flying a heading equal to track, and imagine if you have a port winds, it will push you towards starboard and you eventually reach here. Right? Now let's understand the indication, the RBI indication tuned to A. This is going to be the ADF indication. And how much would that be? That's going to be like 190 or something. Maybe anywhere more than 180 by amount equal to drift. Right? So this is going to be a value that is more than 180. By how much? By the amount equal to drift. How much about the drift is only 180 plus so much of us, because it's a starboard drift. You can see here your track is to the starboard of the heading. Right? Similarly, if I place the aircraft onto the port, say for example, if I have a strong starboard winds, and if I do not compensate for the winds, I'll be drifted towards the port. And let's see the indications here now. The ADF is simply going to indicate where the NDB is. If tuned to NDB-A, then the ADF is going to indicate so much. And how much would that be? This will be a value like 170, 160 depending on the drift, but basically it's going to be less than 180. Right? Now imagine that with this aircraft, so here it is port of track.
Yeah.
Track here it is starboard of track. Right? I'm sorry, I'm finding it difficult to see it, but yes. Alright, now if I tune this particular aircraft towards NDB-B, now what will that indicate? Exactly on track, it indicates 360. What will the value be here? It's going to be a value which is less than 360. 350 or something? Right? Because this head is going to be 360, this is going to be 180. Right? Similarly here, if I tune this particular to NDB-B all the way straight, yes, so this ADF is going to indicate where NDB-B is, and the head of this is 360, it's an RBI. All these are RBI indications, and this is going to be 180. Therefore, what is the value? It's going to be a value which is more than 360, like 10 degrees or 20 degrees and stuff. So it is more than 360 here, straight. Perfect. Let's look at another scenario. I'm moving from NDB-A to NDB-B. This time I have already accounted for the drift here. Say for example, the aircraft is on such a heading, and let's find out what the indication would be. So on track, the aircraft is on track here. What do you think the indication would be when tuned into NDBA? This is head is 360, RBI,
More than 180.
tail is 180. This indication is going to be more than 180. Yes. What about that indicating where NDB is NDB tuned to NDBB? This is going to be more than 360. More than 360 means 10, 20 extra. You can take it as 370, 380 in that region, right? Now similarly, if the same aircraft, the same orientation, which is here, now I'm placing it to the port of the track, and then I'll be placing it to the starboard of the track, and let's see what happens. So the same aircraft is here. Now you have to understand the ADF indication. Now say for example, in this case the aircraft is actually tracking away from the station. You can see that here straight, right? So when I tune this aircraft to the NDBA, the needle is going to point exactly towards NDBA, and what is that going to indicate? It's going to indicate 180.
180.
Right? What about the when tuned to NDBB?
Greater than 360 only.
That's again much more than 360. Yes. Perfect. The same aircraft, if I place it to the starboard of the track, so here it is towards the port of track. Let me place it starboard of track here. Right. Tune to NDBA. It's very obvious here because the head is going to be
More than 180.
yes, it's going to be more than 180. What about this here? Assume that it is tracking exactly towards NDBB, straight.
0.
Therefore, it's going to indicate 360. Yes, exactly 360. So you see different cases here. It can change left, right. Doesn't matter. It's going to be constant. But any given situation, you will still be able to understand whether the aircraft is moving, is on track, left or right of track as well. You see, if you look at the figure here, if you're tuned to both NDBA and NDBB showing 360 and 180, it's easy. It's on track. But what if both the indications are in this hemisphere towards the left of you? It means that the track is towards the left. Towards the right of you. It means the track is towards your right, and therefore you are towards the left. Right? If both the indications are on the left hemisphere or the lower hemisphere here, right? In this case, you can see that both the indications are on this hemisphere, which means the NDB has to be towards your left. As the pilot is traveling this direction, the NDB has to be towards your left. Both the NDBs and therefore your track as well has to be towards your left, which means you are towards the right of the track. So if I tell you that the ADF, the RBI tuned to NDBA and NDBB is indicating 190 and 350, you are towards the right of track. Similarly, if the ADF is indicating 170 and 010, you are towards the left of track. It should be like that. Right? Now in this case also you can say if your RBI towards one of the NDB is indicating a value more than 180 and towards the other NDB is indicating a value less than 360, that is in this case one of the indications is in the upper hemisphere and the other indication is in the so one of the indications in the left hemisphere, other indication right hemisphere, the NDB over here, it's on track. There are different ways by which you can interpret this. Let's look at an aircraft A and B, and now
Another this thing, sir. Why are we are only assuming that the two NDBs are in line with each other?
You are actually flying out of one NDB and moving towards the other NDB through an airway that is defined by the two NDBs. So we're going to start the question. An aircraft en route place A to B reads this thing. So basically it's moving from A to B and the NDBs are A and B, at A and B. So it is actually moving through the airway defined by A and B. Otherwise this won't happen. Right? Now see in this case, let's look at the scenario over here. Let me put the aircraft here. So I've put the aircraft on track with some amount of drift, and I've put the aircraft to the left of track as well, right? So what is this going to read? The actual value is not significant relative to 360 and 180.
More than 180.
This is going to be more than 180 towards NDBA, and this is going to be more than 360 towards NDBA.
Exactly.
What about for this aircraft here? It's very similar to this one, but I've put in such a way that this aircraft is somewhere in between these two. Somewhere here, right?
Yeah.
Let's see what happens now. Towards NDBB is definitely more than 360 by a larger amount. You see? That's definitely going to be more. If you think about it, look at the aircraft here. This is towards NDBB, and what happens now as the aircraft goes up? The ADF is still going to point towards NDBB if it's tuned. Look at this angle actually has increased, right? What about the other one? The one tuned to NDBA. It is still more than 180, but by a lesser amount. So you can see here that the aircraft, in this case you can see one of the values is on one of the hemispheres, and the other indication is on the other hemisphere. The aircraft is on track. What about here? Here also, one of the value is on the left hemisphere, other value is in the right hemisphere. But can you say this is on track? The aircraft will be on track only if two conditions are satisfied. Number one is that one of the values should be indicating above 180 and the other should be indicating less than 180 or more than 360. Number two,
be on track.
These angles should be same.
Should be here.
Exactly same. You see what happens here? This angle is more than this angle. Look at this question here. One is 188, other is 008. So the 8 is constant there. 180 plus 8 and 360 plus 8. Therefore, since they are both same and on different hemispheres of the RBI, you can say that they are on track. Right? The same question, if you had the indications given as 008 and 186. In that case also, one of the indication is more than one side, the other indication on the other side, but they're not on track. In this case, you can see that the aircraft is probably going to be on the starboard of the track. Exactly like this. This is different.
One value is greater than 180.
Yeah.
And the other value is greater than
360. And the values are same. More by 8 degrees. And that is the reason why it's on track. In this case also, one value is more than 180, other value is more than 360. But that doesn't mean it's on track because it's by same amount. One is 8 and this would be 6.
It's suppose, sir, if it said one is 188, the other one is, let's say, 010.
Yeah, so one is 180. One of the indications is 180, other is 0. So I'll tell you how to actually do this question for the exam. But you can understand, I'll keep the values with you, Deepika. We'll come back to the values you just told me, 180 and 010. So do you understand how it's actually working here in general? Right? Now I'll give you an easy way to actually find this out. We'll just reverse draw this whole diagram, and that's the easiest way. So we'll take the values which Deepika just told us. One of the NDBs, one of the ADF is indicating how much? 1010 degrees, and the other is indicating 180 degrees. It's very similar to this diagram here. One is indicating 010.
So I'm saying, let's say if one of the values remain the same, 188.
188, okay, alright.
And the other one was, let's say, instead of 008, 010. So the drift is not the same. Yeah.
No, the drift is the same. It's the angle between the heading and the track. Okay, let's see what's happening. I'll tell you that. Let's draw the aircraft. The normal situation. Just draw a simple aircraft in whichever direction you want. That doesn't matter. Now, draw the circle. This is how you should be doing this question or thinking about this question in the exam, right? Now, you have to understand the ADF indication, draw the circle. Now, simply mark the needles. The one that is pointing towards 010 is ahead of the aircraft. That is why it is 010. The NDB is ahead. Therefore, how will you mark that? That is like this, 010, because we'll take this as 360. Therefore, 010 has to be here. And therefore, where is the NDB? NDB is somewhere here. Distance is not significant here, it is somewhere there, right? Alright, and the needle will always point towards the NDB. Don't draw the NDB here because it's always in line with the needle. Now what about the next one? It's 188. Where will you mark 188? If this is 010, what is this one? Tail exact opposite to that, that's going to be 190. Yes, this is 190. So 188 is going to be somewhere here. Less than that, right? So the needle is going to now show 188. So two different needles here. One like this. I'll draw with a different color just to. This is needle, one of the needles. This is the other one. You see it? Dial with two needles. Now what about this one? This is going to indicate the NDB that is somewhere around here. Right? Let me, distance is not significant here, so let me mark NDB A somewhere, NDB B somewhere here, B, and A somewhere here. Now take a scale and join A and B straight. So where is the aircraft now? Aircraft is to the port of the track, or just like this, the track. This is the easiest way to actually understand. Let's see this particular question here. What we have in this question, I'll just stop this out. Towards one of the NDBs, it is indicating 008 degrees. Towards the other NDB, it is the ADF indication is 188 degrees. Right? Again, draw the aircraft. Draw the dial around the aircraft, the ADF dial. The head of the dial is 360 RBI and tail is 180. Mark them. One of the needles is indicating 008. 008 is somewhere here. Therefore, the NDB B is here, right? And NDB A, it's 188. If this is 008, what is the tail? 188.
188.
The other needle is also exactly indicating 180. The needles are actually coinciding, right? They're actually one over the other in the opposite direction. So where is the other NDB? The other NDB A is here. Now take a scale, draw a line connecting A and B. So what do you realize? That the aircraft is exactly on track. That is because these angles are same. So they are on different hemispheres but same value. Here also they are on different hemispheres but the values are different. And that is why they are not on track. They are towards the port of track. Right? Take another value. Say for example, this is 355 degrees and 165 degrees. Try finding out this one. If these are the indications of ADF, then where is the aircraft? You can drop in the chat. Right. Yes, Deepika, can you drop your answers, please? Where do you think the aircraft is? Oh, yes. What about you, Apeksha? Start from the aircraft, draw the dial, the head is 360, tail 180, one of the needle is indicating 355, and the NDB is here. Okay. The other needle is showing 165, so where is 165? What is the tail?
175.
175. So you can see this helps you to orient and place where 165 is. So 165 is here. Right? So this NDB is here. So you can see if I connect NDB-B and NDB-A using a straight line, that's it. You can see it's port track. It doesn't matter what value they give you, you can still find out. Any given values you can find out where the aircraft would be.